Hey guys, welcome to our demonstration for the problem Koko Eating Bananas. It's a very interesting problem which we can solve using binary search in the optimal manner, and but we have to first figure out how we can solve it in a naive approach, and then we'll move on to the optimal approach. Okay, let's first of all go to the problem statement to understand what the problem is asking us to do. Okay, fine. So Coco loves to eat bananas. There are n piles of bananas. The ith pile has piles I bananas. The guards have gone and will come back in H hours. Coco can decide a bananas per hour eating speed of k. Each hour, she chooses some pile of bananas and eats k bananas from that pile. If that pile has less than k bananas, she eats all of them instead and will not eat any more bananas during this hour. Okay. Coco likes to eat slowly but still wants to finish eating all bananas before the guard returns. Return the minimum integer case such that she can eat all the bananas within a charge. Alright, so what we have understood from this problem statement so far is that Coco is a monkey character and she has a bunch of banana piles in front of her. Okay, so it will be given in the form of an array wherein each element would represent the number of bananas in that pile. And what is the task here is the Coco character wants to eat all the bananas, but she has a time limitation. She wants to eat all the bananas as fast as possible and within H hours. Now, the task given to us is to figure out the minimum value of the K, which is the banana eating speed per hour, which she should eat each hour so that the bananas are finished within H hours. Okay. Now let's see what are the constraints on this problem. The constraints are the number of elements in the banana array will always be less than or equal to 10 to the power 4, and the length of the array will always be less than or equal to number of hours, which will be always less than or equal to 10 to the power 9, and 1 is less than or equal to pile size. That means each element or the number of bananas in each pile will always be in the range of 1 to 10 to the power of 9. Why is constraint checking important? Because that determines what will be the upper limit of the time complexity. So given here that the number of hours will always be in the range 10 to the power of 9, so that means we can never write a you can say a n square solution, because we know that the maximum number of operations that can be operated in, on a standard compiler is 10 to the power of 9. So if you write if an n square solution, that will be 10 to the power of 18, which is not a viable or a feasible solution. So we have to write a solution which is either 10, which is either a order of n solution or a log n solution or maybe a lesser time complexity solution. Okay, so that's why we check constraints. Let's move on to the key observation of this problem statement. Okay, so the observations are total n piles. So obviously an array will be given, so total n different piles of bananas will be there, and each pile has a different number of bananas. Okay, we have to eat the bananas as fast as possible. Now, when I say that as fast as possible, the thing which can pop up in our mind is, okay, why not eat why not eat the maximum bananas at in each hour? Okay, why not do that? I mean, yeah, we can do that if the task was to only eat the bananas as fast as possible, but the task here is we have to eat it fast, but we have to also find out what is the minimum value. So we can never go to the maximum value. Okay, so yeah, find the minimum value of k bananas. It should each, as I said just now, that we have to find out the minimum value of k, so we can never go for the maximum value. Okay, so k represents the banana eating speed per hour. Sorry, moving ahead, let's understand that with an example. Given the piles array, so the elements in it obviously represents the number of bananas in each pile. So 7, 15, 6, 3 are different bananas in each pile of them. And we have h equal to 8, which represents the total amount of time in hours. Okay, so for this input, we have the output as 5, which means that if Coco eats at a speed of 5 bananas per hour, she would be able to eat all the bananas in the H hours. Okay, we can even confirm that. We'll confirm that in the later example. Okay, for now, just see other examples. So for the example 2 also, we have 5 different piles, each having different type of bananas, different number of bananas, and within 5 hours, the minimum speed she should be eating each hour is 30. Okay, and okay, don't just equate 30 with that she has to eat 30 each hour. I mean, 30 is the minimum number of bananas to finish it within H hours. That does not mean she has to constantly eat 30. She can even eat lesser than 30 if 30 bananas are not available in a pile. But yeah, 30 is the threshold. She cannot eat more than that. She can eat lesser than that, but not more than that. Okay, so that is what is meant by minimum number of bananas. Okay, and for the third example also, the minimum number, as you can see, is 23 each hour, so as to finish these five piles of bananas in 6 hours. Okay, what are the observations? The observations are number of piles are always less than or equal to h, as was given in the constraint also, that whatever the number of elements will be in the array, it will never cross h. Okay. All right. What is the second observation? Means if we eat one pile each hour, where we would be able to eat all the bananas before or within 8 hours. Okay. So as it's very clear. But if the number of elements is always less than or equal to h hours, so that means if I have 4 elements and if I have 5 hours, so if I eat even only one banana each hour, so it is going to take me the sum of all the elements, which is sum of all the bananas in the hour. Agreed? Yeah, I think you would pretty much agree with me, because as many bananas as many hours, because I'm taking only one banana each hour. Okay, but what is the question? The question is asking us to eat at a rate of k. What is the minimum number? I mean, if we are gonna eat at a rate of one banana per hour, I mean, h can be very less than the total sum. I mean, if the total bananas are 30 and h is only 8, so I'm not eating within 8 hours. I'm taking 30 hours. So I have to find out k within 8 hours. I have to find out that value of k. Okay. Until and unless one file is finished, she can't eat from that pile. Yeah, exactly. That is a very important point here. That as the question also mentioned, you have to eat from one pile in each hour. And if you have not finished, if you're not able to finish that pile in the first hour, you can eat as much as the value of k, and in the next hour finish the remaining half. Okay. All right. Let's move on to the next slide. All right. Isn't the more the better? Okay, now why is this question being asked to you? I asked the same question in the very beginning of this question, which is, isn't it better that if you want to eat it very fast, can't we eat more maximum number of bananas each hour? Yeah, I mean, ideally we could have eaten if the question was to eat it as fast as possible. But the question is that we have to eat it at a minimum value k. So it just eliminates the maximum eating speed. Okay, so we have to find a value k. All right, let's understand that with an example. Piles given equal to 7, 15, 6, 3. All right, so we have 4 different piles of bananas, each having different number of bananas in each pile, and we have h equal to 8. This is the very first example given to us. Let's understand how we can solve it. Okay, ideally. All right, if the goal was to finish is at it as fast as possible, we would have chosen the pile with max bananas as a value of k. As I already told you in the previous slide, that if the goal was only to maximize, only to eat the bananas as fast as possible, we would have eaten at a rate of maximum bananas. Okay, but the goal is to find out the minimum value. So what we will do, we would then have been able to eat at this rate some hours or less than that. Okay, obviously, because if we have, let's suppose the maximum value is 15, right? So we could have eaten 15 in 1 hour, and if the in the second pile, if the value was less than 15, we could have eaten that as well, and we could have easily able to eat all the bananas within h hours. Okay, now let's try to understand how would we approach it in the very brute force manner. Now tell me one thing: if I want to eat all the bananas, what can be the minimum number of banana I can eat each hour? I mean, if you have to eat bananas, obviously the minimum number can be one. So why not begin with one? Let's try to we'll build the solution one by one. Let's try the number of bananas with one, then two, then three, then four, and see what number we are able to finish all the bananas. Okay. So for k equal to 1, as you can see, if we eat at a rate of one banana per hour, it's clear that the total number of time in hours will be the sum of all the bananas, which is 31 here, which is clearly greater than add and 8, and which we cannot consider for our solution. So let's try to increase the value of k to equal to 2. So if we take k equal to 2, now see here, for the element 7, the first element 7, why am I getting 4 hours? If it would have been 6, we would have taken 3 hours to it. But for element only 7, if we have 7 bananas, why it will take me 4 hours? It should ideally take me 3.5 hours, right? Yeah, that is a good question. But see, as the question told me that you can only eat from one pile in an hour, given it doesn't matter whether it is equal to k or less than k. So you cannot move on to the next pile until one pile is finished. So that tells me that in the first 3 hours you would be able to eat 2 bananas per hour, but in the last hour there will be only one banana left, right? So you have to eat only that one banana in the complete hour, because that is a part of first pile. Until and unless one pile is finished, you would not move on to the next pile. So that means we would have to take the seal. You know that we have two functions in the math library, in Java or Python, floor is taken for the lower bound of a decimal value, and ceil means the upper bound of the decimal value. So if a number is 3.5 and 3.5 lies in the range of 3 and 4, so ceil would be the upper bound of 3.5, which is 4. So that is why we have taken 4 here, and we have to do it for every number. We have to take the ceil value, because if a number is in decimal, we have to suffice with that part. Okay, we have to consider a complete R for that number of bananas. Okay, so for 7 bananas we have taken 4 hours. For 15 bananas it's going to take 8, because again for 14 bananas it will take 7 hours, and then for the next one bananas it will take complete 1 hour. So 8 bananas. Okay, so 8 hours. Okay, so 4 plus 8. Then for 6 bananas 3 hours, and for 3 bananas, let me take a pointer over here, and for this 3 bananas it's going to take me only 2 hours, right? For 2 bananas 1 hour, and 1 banana for next 1 hour. If we sum them up, we are getting again 17. So 17 hours, while we only had 8 hours to finish. So again, it is not a feasible solution. Now let's move on to the k equal to 3. Now when we have k equal to 3, again what we are going to do is we have to find out how many hours it will take for eating 7 bananas. Obviously it is going to take me more than 2 hours, because 3 is the eating speed per hour. So 2 hours for 6 bananas, and the remaining 1 banana again will be eaten in the next hour. So it will take me 3 hours. For 7 bananas, for 15 it's going to take me exactly 5 hours, right? For 6 bananas again 2 hours, and for 3 bananas it's going to take me 1 hour. If we sum them up, we're going to get 11. Again, it is a value greater than 8, so that means that it is not a feasible solution for me right now, right? But again, see, as we are increasing the banana eating speed, the number of hours is coming down. So that tells me that as and when I'm going to increase further, again the number of hours is going to get down. So we'll keep doing that, right? Now let's take k equal to 4. Again, when k equal to 4, so for 7 it is going to take me 2 hours, because for 4 bananas it will take 1 hour, and for the remaining 3 it will take 1 more hour. So similarly, I have taken the sum for other values as well. So in total it's going to take me 9 hours. Again, it's lesser than 17, the previous number of hours, but again it is greater than 8, which is not a feasible solution. We have to eat within 8 hours, right? So now take again k is increased to 5. When we increase k to 5, we are getting these values. So for the 4 different piles of bananas, we are getting 2 hours, 3 hours, 2 hours, and 1 hour. When we sum them up, it's taking us 8 hours, which is exactly equal to 8. Now, so that means what is k our final value? So should we eat at a rate of k equal to 5 bananas per hour? Now, if you remember, in the very first slide, we had the answer as k equal to 5 exactly. But why is 5 an answer? Like, can't we go for k equal to 6, k equal to 7, k equal to 8? Huh? I mean, as we have seen in the previous slides, that as and when we are increasing the value of k, the number of hours is going lesser and lesser and lesser. So that means if we increase k equal to 5 to k equal to 6, the number of hours might also come lesser than 8. Right? Now, the question was that we have to find out the minimum value of k. Now, as you can see, among k equal to 5, 6, 7, and 8, k equal to 5 is the minimum value, and it is also satisfying a condition that we have to eat it within 8 hours. So that means we'll take k equal to 5 as our answer. Okay. So that in that way, if we think a solution could be that we iterate from 1, and we move on to the point where the number of hours is less than or equal to h, and that way we'll be able to find out the solution. Now that is the minimum value. What about the maximum value? Think about it. What can be the maximum value of bananas we eat each hour? Obviously, we have seen in the very first example, the maximum bananas at which we can finish it within h hours will be the pile with the maximum value, right? Yeah, because if we have a pile with 15 bananas and other pile with 7, 6, and 3, so if we eat at a speed of 15 bananas each hour, so any pile which has lesser bananas than that can also be finished within 1 hour. And because 15 is the maximum number, so this will only be there will only be one such pile. So if we are eating one pile each hour, so it will be always less than or equal to h, right? So so that means our answer will always be in the range of 1 to the maximum value in the array. So it makes sense that we run a loop from 1 till maximum of the pile value in the array, and what we do is for each value of k, which is from 1 to maximum of array, we find out the total hours. Does it make sense? Yes, I guess it makes sense, because that's what we have been doing here, right? for k equal to 1 we found out the total hours, for k equal to 2 we found out the total hours it took, for k equal to 3 we found the total hours of total hours it took to eat a banana. So that is what we have to do. We have to run a loop from 1 to maximum of the value in the array, and at each value of k equal to 1 we find out the total hours. Now how we are going to find out total hours? We have to actually divide each element in the array with k equal to 1 and sum them up and just compare that with h. If that satisfies, we just return that value. If not, we move on to the next value of k, right? Okay. So this is the complete explanation of what I just said so far. Okay. Uh, K is the eating speed, and we have to find the minimum as possible. So K is our answer. Okay. And maximum, as I told you, it will always be the maximum banana available in the pile, right? Why is it always the maximum value? Because obviously if we have a banana pile with 7, 6, 15, 3, obviously you can never eat more than 15, because the question says you have to finish one pile before moving on to the next pile. So in any hour you can only eat one pile, and if you are gonna eat only one pile in 1 hour, so you have to find out that pile which has the maximum value, right? So that is why the maximum value can only always be the maximum amount of bananas in any pile. Okay, right. Now let's see what we have, how we can code this. So first of all, if the answer is gonna always lie in the range of 1 to max, so it makes sense that we first of all find out the maximum value in the pile. So that's why we have taken max function over here, and then we define one function called minimum bananas, which takes in the array piles and the number of hours we have to finish it in. Okay, now in that, as I told you, we have to loop. Why we have to loop? Because we have to check for k equal to 1 till k equal to max value, which is the maximum number of bananas in in any of the pile. Okay, now inside that, at each value of k, at each value of I, what I am doing is I'm calculating the hours it's taking me to I'm calculating the hours it's taking me to eat all the bananas at that eating speed. Okay, so that is why I calculate hours. I have defined one more function for that, which is gonna calculate the total number of hours at this hourly speed. Okay, at this hourly speed. Okay, now what I'm doing is, after calculating that value, I'm checking whether that value is less than or equal to h. If that value is less than or equal to h, then I have found out my value, right? So I'll simply return. All right, now below this I have defined the functionality of calculate hours, which is very easy. Obviously, if you are going to calculate the hours it's going to take to eat the bananas, what are you going actually what are you exactly doing? You're actually dividing each element inside the array with that value, hourly value. So that's what I'm doing here. I've defined a variable answer equal to initially 0, and then for each element inside that array, what I'm doing is I'm taking that division of that element with that hourly rate, and I'm taking the seal of that. You remember why? Because we have to take the upper bound. In any hour, if I have found only lesser values than k, so I have to eat the remaining bananas in that complete hour. So that's why the seal of that. Okay, and I am just adding that to my answer variable and that returning that. So that means this function is gonna take me how much time to execute? So if I have a total of n elements inside this array, it's gonna run for n times. So order of n for this complete function. Okay. Now, can you tell me what will be the complexity of this minimum banana function? Now, this minimum banana function is having one loop which is running for from 1 to maximum of the array. So that means the complexity of this outer loop will be the maximum of array. And inside this for loop, you see that I am calling this calculate hours function. So that means I'm calling this function calculate hours for m number of times. So that means it's a loop inside a loop. So if you have to find out the total time complexity, it will be the multiplication of both of them. So that means calculate hours are taking n time, and this loop inside the minimum bananas function, it's taking maximum of the array, maximum of the piles function. So in total, it will be multiplication of both of them. So that is why the total time complexity is coming out to be n multiplied by max of piles. Is that clear? Now it's a bad solution. Why it is a bad solution? Because in the beginning we see the constraint. The constraint was it is the number of values inside the array will be in the range of 1 to 10 to the power of 9. Now 10 to the power of 9, if we take a square of them, because it's a nested loop, 10 to the power of 9 square is 10 to the power of 18. So if we are going to write such a solution, I'm getting a TLE error, which is time limit exceeded error. Now, can we do better? Yes, we have to do better, and we can do better. How we can do better? Using binary search. Now you might be thinking, why, how can we apply binary search on such a problem? Because binary search applies onto an array which is already sorted. Right. Now here we have the array is not sorted. So how are we going to apply binary search on this? Now, let me tell you one thing. We are not going to apply binary search on the array, but on the range. What range I'm talking about? We just saw that the answer will always lie in the range 1, because 1 is the minimum number of bananas the Koko can eat in each hour, and the maximum value is maximum array. So this is the range I'm talking about, and I will be applying binary search on this range. Why? How I can apply it on the range? Because from 1 to maximum, it's a constant range of numbers, and it will always be sorted. So I can apply binary search on this range, right? Now let's say how we are going to do that. So how we can apply binary search? Let's try to understand that with the example, very first example. So as you can see here is the same piles of bananas, the same number of hours, which is 8, but this time instead of linearly going from 1 to maximum of array, that means 1 2 3 4 5, I'm gonna use binary search. How? What I'm going to do is I'll take the low as the minimum number of bananas, and I will take the high as the maximum value available in the array. And then what I'm going to do is I will find out the mid value. I'll find out the mid number of bananas. Okay, once I found out that mid number of bananas, what I'll do is I will pass that mid number of bananas inside the calculate as function, and I will check whether for this value of k, whether this value of mid is it satisfying the relation that the total hours should be less than or equal to k, total number of hours should be less than or equal to h. If it satisfies, what I can do, I can probably think, okay, this can be our answer. I'm not saying that this will be our answer, but I will say this can be our answer. But why I'm saying that? Let me tell you one thing. Let me give you one example of that. So see here. Let's understand this with an example over here. What I'm doing is 1 plus 11, because 1 is low, x is the maximum value in the array, and when I take the mid of that, when I calculate the mid, so I will just find out that it is 6 bananas. When I pass 6 bananas per hour, so what is the total number of hours? Let's try to calculate here. So for 7 bananas over here, it will take me 2 hours, because 6 bananas in the 1 hour and 1 bananas in the next hour. Okay. For 15, it will take me 3 hours straight, because 12 bananas in 2 hours and the remaining 3 bananas in the next hour. So it's gonna take me okay, what is this, what I'm doing here? Okay, there's a mistake over here. Let's correct this. So it will be 1 plus 3. All right, and for 6 it will be 1, and for 3 it will be also 1. So in total it's going to be 3 plus 3, which is 6, which is less than 8, right? So instead of this, it will be 1 plus 3 plus 1 plus 1, right? So in total it will be 6 hours, which is less than 8. So that means this can be a probable answer. But why I'm saying it's a probable answer, let me tell you one thing. So if I find out that 6 is a total number of hours it's going to take us to eat all the bananas, I want to make sure that it is our answer, right? It is our answer, because maybe there can be some numbers also, there can be a value of k which is even lesser than 6, and still I'm able to eat within 8 hours. Maybe I'll eat it within 7 hours or within 8 hours. So for I have to find out the minimum possible value. So even though 6 is a lesser value than 8, in order to make it sure that it is the final answer, we have to look in the left half of the range. So what I will do is I will decrease my range from low to mid minus 1, right? So that's what I do here. What I did is now I will take high equal to mid minus 1, which is previously the mid was 6, so now it will become 5. Now I'll again recalculate the mid. So mid will be now 1 plus 5 by 2, which is 6 by 2, which is 3. Now I found out that 3 bananas per hour is our new mid. So I will try to find out what is the number of hours it's going to take me at 3 bananas per hour eating speed. So for now, it seems that it is taking me 10 hours, which is clearly greater than 8. Now why? We have found a value which is greater than 8. Now that is not a feasible solution. What we will have to do next? Now since 3 is not giving us the right answer, and it's a lower eating speed, so that means we have to increase our eating speed a bit. So that means what I have to do is I have to, in binary search, what we do, if we found a lower value, so we go on to the higher in the right part. So that means we have to shift our low from low to mid plus 1. So this time if I keep doing it, ultimately it turns out that at a point k equal to 4, we are crossing the mid value. Right. So as you can see over here, previously it was k equal to 3. So since the value for low was very less, we tried to move on to mid plus 1. This time it becomes 4. So when I again recalculate the mid, it turns out to be 4 again. So at k equal to 4, we find out that it is exactly matching our speed. You see, previous in the very first iteration, we found 6. So we wanted to make sure that 6 is the least possible answer. If it was, then we would not find any value lesser than 6. But it turns out that there is a value even lesser than 6, and it is even satisfying other conditions. So at k equal to 4, we are finding exactly 8 as it's going to take to eat all bananas. Now even now we are not sure that 4 is the answer. So what we'll do, so when we are not sure, we'll again check in its left half. So in order to check in its left half, we have to decrease the high from we have to decrease the high to mid minus 1. So this time low will be 4 here and high will be mid minus 1. So previously high was your sorry, previously high was 5 and now it has to become mid minus 1. So previously mid was 4, it will become now 3. Now as you can see, high has become 3, low is 4. I mean, only always when you have low and high, okay, low is at a lower point than high. Whenever high becomes lesser than high, whenever high becomes lesser than low, that means high is in the wrong direction. High has crossed low. High should never cross low in binary search. If high crosses low, that means the binary search is over, because that is the condition of binary search, while low is less than or equal to high. As and when high will cross low, that means we have crossed our we have crossed low and high, and at that point binary search will stop. So whatever will be the last result of mid will be our answer. Okay, now let's try to code this up. So again, we are not changing the calculate as, because calculate as still has to go through all the values to calculate the total number of hours at that speed. So we are not going to change that. What we have actually changed is the linearly traversing from 1 to maximum. Okay, so instead of linearly having a order of maximum value, we are just gonna apply binary search on the range. Okay, so range 1 from 1 to maximum m. Okay, so as you can see over here, this is low, this is high, which is maximum. And then what we do is, why I have taken answer equal to m initially? Because in the worst case, worst case, the answer will be the maximum value available in the array, even though we have to find out minimum value. But in the worst case will happen when there is only h number of values in the array. Let's suppose there are 5 hours and you have only 5 piles in total, and if you cannot eat lesser than the maximum value, because if you do so, then in some pile you would be ending up with some number of bananas, and you would not be able to finish that in h hours. Okay, so that is the initial answer for, we have taken maximum value. And we can even take a maximum, we can even take a integer max, that it doesn't matter. You can just have a very high value, because we have to find out low value, so it doesn't matter what we take here as answer. Okay, all right. So while low is less than high, what I'm doing is I'm finding out the minimum value. All right, and I'm passing that mid value as an argument to this calculate r function. Okay, and if this total r's which is coming out from this calculate r function, if it is less than or equal to h, if I found out a lesser value, so what I need to find out, I have to make sure that it is the lesser value. And in order to make sure of that, I will look in the left half. I'll look into the left half of that value. So that is why I have reduced my high to mid minus 1. Okay, and if I have not found out total hours which is less than h, what I'll do is I'll increase my low to mid plus 1. Okay, so that is why else part is over here, and in the end I just need to return answer. So how much time it's going to take me? Now again, bear in mind, calculate as is the function which I have not touched. So it is going to take the same order of n time. I've only changed this implementation, which was initially the linear search, and now it is binary search. Now binary search takes a log of n time. Now can you tell me, is it log n over here? No, it's not log n, clearly, because I'm not traversing over the entire array. What I'm traversing is over the entire range. So what is the range? The range over here is 1 to maximum of the array. So that means it will be logarithmic of the range, logarithmic of maximum value. So that means that overall time complexity will come out to be order of n for the internal calculator function multiplied by log of maximum value. All right. So that is our time complexity. So initially it was n square solution, wherein now it has become an order of n log n, you can say. I mean, even though it's not n exactly, it is maximum piles, log of maximum piles, but yeah, it is of the order of n log n. Right? So it's a better solution than that, and that's how we solve it in an optimal manner. Any questions you have for this question? I guess it should be very clear. And thank you for tuning in and listening to the demo. Yeah, and I'll see you soon. Bye bye.